Good morning, students. Last class you have learned how to find out the motion of connected bodies when two bodies connected in horizontal plane. That's what you have practiced in the last class. I believe that you all practiced that equation. It is one of the important question in this unit. And today we are going to discuss a new topic, that is what motion of connected bodies when two bodies connected in different position, how the acceleration is getting affected. We can connect these two bodies vertically, horizontally, or in an inclined plane. We can allow these objects to move. So when we are allowing this object to move in vertical direction or horizontal direction or in an inclined plane, the acceleration may vary some extent. This acceleration we are finding, when this acceleration vary, there is a reason behind this, because there is a tension produced between these two mass. So this is what the acceleration is varying some extent. So we can consider two cases. Case one, vertical motion. This is what you can see the diagram in textbook page number 126. So this is how two bodies connected in vertical direction. This is what we consider two object of mass m1 and m2, which is connected in an inextensible string. There is a small string which is used to tie these two mass, and now it is allowing to move. You see, this is what pulley we will say, pulley. So these two masses are allowing to move over this pulley. When this moves, what will happen? This mass is greater. This m1 is greater than m2. So m1 is greater than m2. So then what will happen? The m2 move downward direction. M1 move downward direction and m2 move upward direction. So the acceleration of this m1 is downward and this m2 acceleration is where? Upward. This is what you can see in this diagram. Now this m1 is moving downward, this mass m1 is moving downward, it is due to the gravitational force mg, W equal to mg. There is always a downward force mg. Here also, due to this mass m1g is acting downward, so that this mass m2 is going upward direction. So you can draw a free body diagram for this mass m1 and m2. Suppose we are taking mass m2. This is what mass m2. Mass m2. Upward tension. Downward water. Downward gravitation. m2g. This is what a free body diagram for which one? Mass m2. The same you draw free body diagram for this mass m1. M1 mass, downward m1g, gravitational force, upward water, tension. And you know this unit vector. This is what using unit vector, x direction, y direction. This is what residual. So here we need what? Only x and y. So this is enough. Now you see, you know y means what? Y means j vector, unit vector j. Here, this direction what? I unit vector. This is plus sign, this direction minus sign. This direction what will come? Minus j. This unit vector is very important. We need this unit vector in this part. Okay, so remember this is unit vector plus j, this direction what, minus j, this direction I, this direction minus I, plus I, minus I. So remember this what are unit vectors. Now we can find out the acceleration. First you take apply Newton's second law. We know the formula Newton's second law, F is equal to ma. So apply this Newton's second law on mass m2. That is what, mass m2. Applying Newton's second law on what, mass m2. So this diagram you take. Now you see, gravitational force is downward. Gravitational force downward. And here what? Tension acting upward. And our formula is F is equal to ma. What are the total forces acting? Gravitational force and tension force. So T acting upward. What direction? What direction? J. Unit vector J. So T J unit vector. Now downward what force is acting? M to G. M to G. So M to G. What is this direction? Downward direction is what? Minus J. So that's what we are using. Minus J equal to ma. M here what M? Mass M2 acceleration. Now acceleration which direction? Which direction? You see this M1 is moving downward. M1 is moving downward. This M2 is moving upward. Upward means what direction? J direction. Plus J. Plus J. This is what we are writing equation from this free body diagram. Now you see, comparing this component. Comparing this component means just without this component you write this equation T minus M2 G equal to M2 A. This you take it as equation 1. Now similarly the same thing you do this for water mass 1. So M1. So what do you do? Applying Newton's second law on mass M1. So what will come? Take this mass, this one, upward water, tension, downward M1G. This is water, total force. Upward tension, upward. Upward means what direction? Plus J. J unit vector plus J. Now downward what force? Downward M1G. M1G. So plus M1G. Now listen here. This is what direction? M1G. M1G in what direction? Downward direction. Downward means minus J. So plus into minus J equal to what will come? MA. MA means here M1 and the acceleration. Acceleration is what direction? Acceleration what direction? Downward. Downward means minus J. Okay. Now again the same thing, comparing the components on both sides. So just remove all these components now. So T minus M1 G equal to minus M1 A. Now what you have to do means you have to just change this minus symbol. So rearrange and write this equation. So what you can write the same equation you can write in terms of what? Minus M1G plus T equal to minus M1A. Now, what are multiply this equation with minus. So, what will come? M1G plus T equal to M1A. This you keep it as equation 2. Okay. Now, what we have to do means, this equation. So, what will come here? You see again one more time in this equation. Now the equation is like this. Now multiply this equation with minus. So multiply, you can keep this equation 2. Multiply equation 2 with what are minus. So minus into minus plus M1G. Minus into plus minus. So minus T equal to minus into minus plus M1A. This is equation 3. Now what you can do is you can add the equation 1 and 3. So add equation 1 and 3. So equation 1 is add equation what are 1 and 3. When we are adding the equation 1 and 3, we will get the, you see what we will get the, so now I am going to add the equation 1 and 2, 1 and 3. So what will come? Equation 1 T minus M2 G. Now this left side of equation 3 you write plus M1G minus T equal to, now RHS side you write M1A. What are M2A plus M1A. Now you know here plus T, here minus T. So cancel this T and T. So what will come remain? What will be remaining? Minus M2G plus M1G equal to M1A plus M2A. Now what you can do is rearrange this. M1G minus M2G equal to M1A plus M2A. Now here G common, here A common, take it outside. So M1 minus M2 into G equal to M1 plus M2 into A. Now acceleration you can find out acceleration. So M1 plus M2 into A equal to M1 minus M2 into G. Now what you can do is acceleration find is equal to M1 minus M2 into G. M2G divided by what? Divided by, we have to take this M1 plus M2 here. So M1 plus M2. Now this you keep an equation 4. This you can take equation 4. You see from this step again we are finding A. So M1 minus M2 into G divided by what? M1 plus M2. We are taking what? Cross multiplication. Now what you have to do means you have to find out the tension. That is what? We are finding the tension. To find out the tension, what you are doing means just substitute this acceleration value in equation 1. So substitute down equation 4 in equation 1. So where is equation 1? We can see here T minus M2G equal to M2. Instead of this A, you have to substitute this value. So m1 minus m2 into g by m1 plus m2. Now take this, we have to find out t, so take this minus into g that side. So t is equal to m minus m2g, when going that side it will come plus m2g. Then what are? Take this m2 into m1 minus m2 into g by m1 plus m2. Now what you have to do means take this LCM. So what will come? What will come? Listen. T equal to m2g into m1 plus m2 plus m2. See, T equal to m2g into m1 plus m2 plus what are m2 into m1 minus m2 g divided by what are? Divided by m1 plus m2. Now this is what taking the LCM, multiply this inside. So T is equal to m2 m1 m1 m2 g m2 plus m2 m2 g plus what will come? m2 m1 m1 m2 this g minus what will come? m2 m2 into g. Okay. Now divided by m1 plus m2. Now you know plus m2 m2g minus m2 m2g cancel. So what will come? T is equal to m1 m2 g plus m1 m2 g divided by m1 plus m2. Okay. Now T equal to m1 m2g plus m1 m2g. So 2 m1 m2g divided by m1 plus m2. This is what our tension equation. Again remember how you are finding the tension. First you draw the free body diagram for mass m2 and mass m1. Then what? From that you have to take equation. By applying the Newton's second law, you have to find the equation by using the vector component. So you will get the two equations. First equation already I wrote. What will get? T minus m2g equal to m2a. That is what our first equation. This is our second equation. Then what are? Adding the equation 1 and 2. From that we are finding the acceleration value. Then what are? Substituting this acceleration value in equation 1. So we will get a tension to m1 m2 g divided by m1 plus m2. Then this acceleration value you can write it for mass m1 and m2 in textbook page number 127. It is given a is equal to minus m1 minus m2 divided by m1 plus m2 with the unit vector j. For that m2 mass m2 also acceleration is given. A is equal to m1 minus m2 divided by m1 plus m2 into j vector. Now the same thing. Same derivation. How we can find it out? In horizontal direction. Case 2, horizontal direction. For that, assume that one table like this. One table, we are keeping our mass M1 and tying this in an extensible. Here one pulley, here one another mass. So, like this one diagram you can see in page number 127. Here mass M1, mass M2, here M1G. And this is what two body which is connected in horizontal plane. Two body which is connected by using an inextensible string and kept on a table. That is what now you can see. What you can see, it is very simple derivation like last one. You see, first you have to draw the free body diagram for this. For mass M1, how you can draw? Upward tension, downward M1G. For mass M2, here there is a force, downward force. Here there is a force, upward force. Here there is a force, tension. So you can draw M2, upward force, downward force, tension force. Upward normal force, downward what force? Gravitational force M2, G and tension this direction. These are the three forces which is acting on mass M2, and these are two forces, tension and the gravitational force which is acting on the mass M1. This is what the free body diagram. Now, what are the forces acting? Downward force, downward force. In mass M2, what are the forces? Downward force, what are the force? Downward force, gravitational force, upward force, normal force and the tension force. Here acting two force, upward force, that is tension, downward force, gravitational force. So, what you have to do means, next thing what we have to find out the equation. We are going to derive the equation. For that the same thing, applying Newton's second law for mass M1, then applying the Newton's second law for mass M2. First you have to apply the Newton's second law for mass M1. So, mass M1, you know Newton's second law equal to Ma. So, applying Newton's second law on mass M1. So, when you are taking the forces in mass M1, upward tension, downward what? M1G. So, upward tension, what direction? Plus J. Upward tension, so plus J unit vector. Downward minus J, so minus M1G, J unit vector equal to Ma. Ma means acceleration, downward means what direction? Minus M1A. Now J unit vector. Now comparing the component, so you can write this equation M1G equal to minus M1A. This you can keep equation 1. Now you have to find the tension in what? Mass 2. So for that, apply Newton's second law for mass M2. Mass M2 F equal to Ma. You see, when you are taking this mass M2, first upward force, downward force, this direction on force. So take this tension what? For this mass M2 tension T, this direction. This what direction? Xi direction. Okay, I unit vector. This is along x direction, this is along what? Y direction. That is what? 2 tension. Equal to, because in this direction no gravitational force, so only T is there. Now what will be there? Here acceleration also there, acceleration. So you can write what? MA. MA means mass. What mass? M2A. Acceleration. What direction? The same I unit vector. Okay, so combining the components, so T is equal to M2A. This is equation 2. Now this direction, upward water N, upward N and J unit vector, downward M2G. So downward means minus J. So M2G, J unit vector minus equal to, is there any acceleration this direction? This is a mass, upward force, downward force. Any object which is at rest, there will be upward force and downward force, but no acceleration. So acceleration is 0. So n equal to, we can write comparing the component n minus m2 g equal to 0, we can write so n is equal to m2 g. This you can keep equation 3. Now what you can do is, now substitute, what you can substitute means this t value you can substitute in equation 1. Substitute 2 in equation 1. So instead of this t, m2a minus m1g equal to minus m1a. Now rearrange and write so minus m1a, take this side up, m1a plus m2a. Take this minus m1g that side up, so plus m1g will be. Now m1 plus m2, a taking commonly outside, m1g. So a is equal to m1g by what are m1 plus m2. This is acceleration value. Now what you have to do means, this you take equation 4, substitute equation 4 in equation 2. Substitute this acceleration value here. So t is equal to m2 into m1g by m1 plus m2. So what will come? m1 m2 divided by m1 plus m2 into g. Okay. So when we are comparing the motion, vertical motion and horizontal motion, in vertical motion we got what are 2m1 m2g we got divided by m1 plus m2. This is what for vertical motion tension we got. This is horizontal motion tension. So when we are comparing this vertical motion tension and horizontal motion tension, it is clearly given what are this tension which is producing in a horizontal table, that is what half. Here we see 2 times, here only 1 time. So where tension, here tension producing during horizontal motion, it is what half. Then what this motion in a vertical direction. So this is what our derivation. So my dear students, everyone, practice this. It is very simple. In page number 126, 27, 28, you can mark it down and you can practice it. See you. Bye bye. Thank you.